But investigators concluded that it wasn't terrorism that took down Flight 587, and they knew that because of what they found on the airplane's black box.
When a plane goes down, almost everything is destroyed. Metal breaks apart, fire spreads, and what's left often looks beyond recovery. Yet there's one object investigators always manage to find: the black box. It's usually sitting there, scorched and battered, but still alive with data. Somehow, it survives what nothing else can.
What the press calls the black box is actually two orange flight recorders. The idea dates back to the 1950s, when the first commercial jet had 5 accidents in its first 2 years of passenger service, and investigators realized how useful it would be to have a record of what was happening on the plane before the crash.
Funny thing is, the black box isn't black at all. It's bright orange so rescuers can spot it easily in wreckage or underwater. The name stuck from the early days when flight recorders were smaller and darker. And it isn't just one box, there are 2. One records everything the pilots say and hear in the cockpit. The other captures flight data like altitude, speed, and engine performance. Together, they tell the complete story of the flight's final moments. For something so small, it's built like a tank. Inside the bright shell sits the memory unit, which stores all the data. That memory is wrapped in insulation, then covered with layers of aluminum and titanium. Every part of that design has one job: to keep the data safe through impact, heat, and water. Before a black box is allowed on any aircraft, it's put through tests that sound like torture. Engineers crush it, drop it, and burn it until only the toughest survive. It has to handle an impact that's thousands of times stronger than gravity, like hitting a wall at 500 kilometers an hour. Then it gets blasted with fire hotter than molten lava for an hour straight. After that, it's baked in lower heat for 10 more hours to see if the data still holds. Next, they test it underwater. The box is submerged for 30 days and pressed with forces as strong as those 2 miles deep in the ocean. It even has to survive being pierced and smashed. Only after passing all that punishment can it go into a real aircraft.
They do have a beacon that activates underwater and sends an ultrasound signal every second for 30 days. That signal can travel through 14,000 feet of water.
Each recorder also has an underwater beacon attached. If a plane crashes into the sea, the beacon automatically turns on and starts sending out a ping every second. That signal can be heard up to 14,000 feet below the surface. The beacon's battery lasts about a month, which gives search teams time to locate it. In some cases, though, it still takes years. The recorders from Air France Flight 447, for example, were found almost 2 years after the crash, deep in the Atlantic. When they were pulled up, the data was still readable.
Investigators needed information from the second box, the flight data recorder. It captures at least 88 types of data about the plane's position and instruments for the past 25 hours. That data feeds into computer animations of what happened before the recorder lost power.
The amount of information inside is impressive. The cockpit voice recorder holds the last 2 hours of sound. The flight data recorder holds 25 hours of readings from hundreds of sensors. It's always recording and overwriting the oldest data. So when a crash happens, the final moments are locked in. Investigators can then hear the pilots talking, alarms going off, and every little detail that led up to the event. It's like rewinding the story of the flight 1 second at a time.
The recorders are installed near the tail of the planes where the force of the impact is somewhat lessened, and the memory boards are kept in steel or titanium cases and surrounded by materials that protect against high temperatures. Often, the rest of the box will be destroyed, but that doesn't matter as long as the memory unit is intact.
Placement matters too. The boxes are usually kept in the tail section of the plane, since that area often stays intact during a crash. In many accidents, the black box has been found thrown clear of the wreckage, but still perfectly functional. That small design choice has saved countless investigations from going cold. People sometimes ask why all this data isn't sent live to the ground instead of being stored on a box. The truth is, some modern aircraft do transmit bits of data mid-flight, but sending everything from every plane in the sky would need enormous amounts of bandwidth. For now, keeping it safely stored inside the aircraft remains the best option. There have been rare crashes where the boxes were too damaged to read, but most of the time, they make it through. When investigators open them, those recordings become a voice for the flight. They explain what went wrong, help fix design flaws, and often prevent the same mistake from happening again. The testing process behind these boxes is extreme. Engineers slam them into concrete, drop heavy weights on them, even shoot projectiles to see if the data chips stay intact. Brutal, but it works. Out of all the pieces of technology in aviation, the black box is the one that can be trusted to tell the truth when everything else fails.
And the black box data revealed that the pilots lost control of the plane over the course of about 10 seconds. And this line in particular stuck out.
It's not there to save lives during a crash, but it helps save lives afterward. Every safety rule, every improvement in aircraft design owes something to the information recovered from these boxes. They're the silent witnesses that keep learning from tragedy. Next time you board a plane, somewhere in that aircraft sits a small orange box, tougher than steel, ready to face fire, water, and impact. It never stops recording, and it never forgets. When everything else is gone, it's the black box that makes sure the story is still told.